Okay, so we've graphed some functions. We're going to look at some operations with functions. Okay, so there's two different types of things. This is operations with functions. This is not composition of functions. We'll talk about that in the next lesson. But in this one, we're just talking about your general, excuse me, addition, subtraction, multiplication, and division. So functions can be combined using addition, subtraction, multiplication, and division to create a new function. So this is one type of notation you could see. Another type of notation that would be the exact same thing. So this is f plus g of x. Could be written as f of x plus g of x. And then subtraction, so f minus g of x could be f of x minus g of x. I mean, this is kind of a little less to write, but I kind of prefer this way because it makes more sense when you're substituting. F times g of x would just be f of x times g of x. And then f divided by g of x would be the same as f of x over g of x. Okay, so to talk about the next set of stuff, I want to talk about first the different ways to say this. Okay, so this is addition, which means this is the sum of two functions. Subtraction means that this is the difference of two functions. Difference. Multiplication means that this is the product of two functions, and then the quotient. Okay, so those are words that you should be familiar with your basic operations. Okay, so this is not new. Okay, you've done this before. One thing that maybe you talked about but definitely wasn't focused on is the domain. So that's what makes this the pre-cal version of that. So you can't just be like, oh, I know how to do this. Well, do you really know how to find the domain of the combined functions? So it says the domain of the new function is the intersection. So the intersection of two things, more things, whatever, is what they have in common, what they share. It has nothing to do with a passing through. Okay, so the intersection of two things is what they have in common. The intersection of the combined functions, so the domain of the new function is the intersection of the combined functions. The domain is further restricted with the quotient function to exclude values in which g of x equals 0. Now, this really should be said differently, and I did not think to fix this. On all of these examples, and maybe not all of them, I think, okay, so maybe on all of these examples, g becomes the denominator. So really it should be where what g of x is the divisor or the function on the bottom, okay? Function on the bottom. Of the division, okay? So when you take like f of x over g of x, so it means in general, like with this specific example, the reason they're using g of x is because this is how we're defining it. But obviously, I could do g of x over f of x, and if I did that, then f of x couldn't equal 0. Basically, the denominator can't be 0. Whatever's in the denominator, okay? So maybe that's how I should have put it, function on the bottom. Couldn't come up with my words there. I'm going to change that to denominator. Makes a little bit more sense. Oh, chutes and ladders. We'll fit my words, so I'm going to do it. Denominator. Okay. So let's look at how this works for our domain, because it says to, given the f of g, find each new function and state its domain. Right? So in order to figure out its domain, it's the intersection of the two, so I have to know the domains of both of these. All right, so the domain of, this is going to graph a quadratic. That domain, all real numbers. This is a line, all real numbers. Okay, so the intersection of all real numbers and all real numbers is all real numbers. Okay, so the first thing I'm going to do, f plus g of x, so that is going to be equal to, well, f of x is x squared plus x, and then plus g of x, which is 3x minus 1. Okay. Anytime you substitute something in with more than one term, I'm sorry, guys, my brain is just like mush, and I can't even get good words out. you really should put them in parentheses. So when we do this, these parentheses don't really do anything because it's addition, but I'm doing that so it's pretty safe there. So then this equals x squared plus 4x minus 1. So I've simplified it as much as I can. So then I state that this equals f plus g of x. Notation, notation, notation. So there is the new function, and then I have to state the domain. And for this, we're going to do the domain in set notation because it makes a little bit more sense here. So the domain here is all real numbers because it's the intersection of these two, which makes it all real numbers. Right? So then we subtract f minus g of x. So f of x is x squared plus x minus, put that in parentheses, minus 3x minus 1. And here, these parentheses totally matter. The first ones don't really do anything, but the second ones do because I have to subtract both of these. So I'm going to get x squared, then I have x minus 3x, so that's minus 2x, and then minus a negative 1 is plus 1. So that is equal to f minus g of x. Then the domain, all real numbers. Okay. I'm going to multiply them now, so I get x squared plus x times 3x minus 1. All right, so then when I multiply, I'm going to get x squared times 3x is 3x cubed. Then x squared and negative 1 minus x squared, x times 3x, 3x squared, x times a negative 1 minus x. And then I can clean that up a little bit, and I get 3x cubed plus 2x squared minus x, and that is f times g of x. One of the reasons I don't like this notation as much, but it's lesser right here, so it's fine, is that this little dot here means multiplication. It's not the composition. And when we do composition, it's just a little tiny open circle, so it can get a little confusing sometimes. But, all right, so there's that. And then my domain here, all real numbers. All right, so then the quotient, f over g of x. So this gives me x squared plus x over 3x minus 1. Okay, so I want you to think, can I cancel these x's out right here? What do you think? Or even if I factored out an x in the numerator, could I cancel it with this? No, that's a big fat no. Right? If I could factor out the GCF in the numerator and the denominator and something would reduce, that'd be great. But that's not going to happen here. So this is f over g of x. The domain here is not necessarily all real numbers because it says the domain is further restricted with the quotient function, and that's what this is, to exclude values in which g of x, or the denominator function, equals 0. So that means that g of x can't equal 0. So here's how I'm going to figure this out. I'm going to say g of x can't equal 0. Well, what is g of x? This is g of x. So 3x minus 1 can't equal 0. Then I solve for x. So 3x can't equal 1. So x can't equal 1/3. So that helps me write my domain over here. This is my answer. And then, well, it's part of my answer. The domain part of my answer, we're going to write it in set notation. So it's the set of all x's such that x does not equal 1/3. And again, this is it's the set of all x's that belong to the real numbers, but we're just leaving some of that out. We're kind of easing you into that notation. And this is my domain. Because as you know, you can't divide by 0. All right, let's look at number 2. So here, I've got f plus g of x. So that will give me, that's x squared plus 9 plus the square root of x. All right, well, those parentheses really don't do anything for me here, so I don't necessarily need them. Pretty much done. I'll just write x squared plus the square root of x plus 9, and that equals f plus g of x. There's really nothing else we can do. I should have written out these domains here. Okay, so here, this is a parabola, so this is all real numbers. This is the square root of x, right? So I need to know what my domain is here. Well, you can think about it a couple of different ways. Is that, can you take the square root of a negative number and get a real answer? And the answer is no. So I can take the square root of 0 and anything positive, so it should be anything greater than or equal to 0. The other way that you can think through some of these is think about what this graph looks like. This is a parent function. You should know what it looks like. It looks like this. So what's the domain of that? Well, all the numbers greater than or equal to 0, right? So again, we're going to say that this is the set of all x's such that x is greater than or equal to 0. Okay? So now let's talk about the intersection of these two things. The intersection of these two domains is what they have in common. Well, this is all the real numbers that exist. This is only the real numbers that exist that are greater than or equal to 0. So the two things that what they share this entire domain. So the domain here is the set of all x's such that x is greater than or equal to 0. Okay. So then we can subtract f minus g of x. This is going to give me x squared plus 9 minus the square root of x. Well, can't really do much more than that, combining like terms. So this is x squared minus the square root of x plus 9, and that is equal to f minus g of x. Okay. Then my domain. So for A, B, and C, for addition, subtraction, and multiplication, the domains should be the same because it's the intersection of those two. So this is just the domain, set of all x's such that x is greater than or equal to 0. All right, so then I'm going to multiply. So I've got x squared plus 9 times the square root of x. Okay, so now I'm going to distribute so that x squared times the square root of x is just that, x squared times the square root of x. Plus 9 times the square root of x is 9 times the square root of x. That's all I can do. So that is equal to f times g of x. And my domain then, the set of all x's such that x is greater than or equal to 0. All right, f divided by g of x. So this one is going to be x squared plus 9 divided by the square root of x. Okay, no canceling there, but I do need to rationalize my denominator. Okay, so I'm not allowed to have a square root in the denominator, so I'm going to multiply this by the square root of x over the square root of x. When I distribute in the numerator, that's going to give me x squared times the square root of x plus 9 times the square root of x all over x. Okay, so I can't cancel these out. There's no reducing. If I could factor out an x out of both the terms in the numerator, then I could reduce, but I can't here. So f over g of x equals x squared times the square root of x plus 9 square root of x all over x. So there's that part. Then I got to talk about the domain. So remember, this is the quotient. All right? So the quotient says the denominator function, g of x, cannot equal 0. So over here, g of x cannot equal 0. G of x is the square root of x. It cannot equal 0, which means that x cannot equal 0. So my domain here is the set of all x's such that x cannot equal 0. And we're done. Okay, so we're going to I mean, I think hopefully you've gotten the addition, subtraction, and multiplication and stuff down. So we're going to do kind of bits and pieces of these back here and mainly talk about the domains since that's really the new part. So on number 3, we're going to skip A and B. And somebody asked me a good question today, and I probably haven't made this clear. If I skip anything on the notes part, you do not have to go back and do it unless I say you need to go back and do it and check yourself. Sometimes I know there's way too many examples, and it's easier for me just to use what I have than try to edit it even more than I already have, because sometimes it's not as easy as you'd think. So you can go back, and I would be happy to check them if you have questions, but you don't have to go back and do them. So we're going to start with C. So first of all, I need the domains of these. So this is a cubic function, right? And all I did was stretch it, so my domain is still all real numbers. This x squared minus 4x, that's a parabola, so it's still all real numbers, okay? So I'm going to do C, f of x, which is 2x cubed times x squared minus 4x. And then I distribute, right? So when I multiply these two, I get 2x to the 5th minus 8x to the 4th. And that is f times g of x. Right, then my domain is all real numbers because it's the intersection of those two. Then when I get to D, I have 2x cubed over x squared minus 4x. Now, can I cancel this x cubed with this x squared and have an x left up here? The answer is no. But I can factor out a GCF. In the numerator, I'm going to still have 2x cubed. In the denominator, I'm going to have x times x minus 4. So now that I have that, when you have addition and subtraction, they're held together like glue, and you can't just cancel things out. This is multiplication. These two terms are being multiplied, so I can reduce some of this. I can cancel this x out and make this a squared now. So then that means that leaves me with 2x squared over x minus 4, and that equals f over g of x. So now the domain. The domain, the denominator function that we put in, as we put it in, the actual g of x, cannot equal 0. Okay, it's not the reduced part. I can't just take the denominator and say it can't equal 0. It's the g of x function. That's important. So g of x cannot equal 0. That means that x squared minus 4x cannot equal 0. All right, so I'm going to factor this. Okay, when I factor this, I'm going to get x times x minus 4 cannot equal 0. Well, I have two zeros here. I can't forget this one. That means that x cannot equal 0 and x minus 4 cannot equal 0, so that means that x cannot equal 4. So I have two of them. So I can say it's the set of all x's such that x cannot equal 0 or 4. Right? The domain is the new part. You got to make sure it makes sense to you. Now, 4 and 5, we're probably going to do most of those just because of some of the work that shows up in there. And I know these boxes are not that giant, but remember, you can expand them on your tablet so that they take up the whole screen and make it way easier to write in. Okay, so let's look at these functions here. So these are rational functions. We haven't talked about them yet, but it's definitely an Algebra 2 thing. So we should be able to come up with our domains. This one here, I know that I cannot divide by 0. So basically, it's all real numbers except x can't equal 0. So it's the set of all x's such that x cannot equal 0. Here, I can't divide by 0, so that means x can't be negative 2. So it's a set of all x's such that x cannot equal negative 2. So when we talk about the intersection of those two, what do those two things, when I put them together, have to have everything? So it's all real numbers except no 0, and all real numbers except no negative 2. So my new domain is all real numbers except it can't be 0 or negative 2. So that's going to be my domains for A, B, and C when we get there. All right, so let's look at A. We're going to add these. This is equal to 1 over x plus 2 over x plus 2. Now, if you struggle with fractions, you better go get yourself some help with fractions because we're going to be fraction crazy. And you just have to understand your basic fraction rules. Multiplying and dividing and adding and subtracting fractions is, you just have to be able to do it to survive. So in order to add fractions, I have to have a common denominator. So my common denominator is going to be x times x plus 2. All right? And so that means that this fraction has to be multiplied by x plus 2 over x plus 2, and this one has to be multiplied by x over x. So this is going to give me x plus 2 over x times x plus 2 plus 2 times x over x times x plus 2. Now, I could distribute that, right? But I don't know that I want to. Maybe I will want to, maybe I won't. I don't know. We'll see in just a second. But we're going to, I definitely don't want to cancel this x out here because then I don't have a common denominator anymore because I just put it there. So make sure you don't get yourself into a cycle of craziness there. And so then this is going to give me x plus 2x is 3x plus 2 over x times x plus 2. And again, no need to distribute because sometimes you will want to have it factored out and it's fine just like it is. This is f plus g of x. Okay. And then my domain is going to be the set of all x's such that x cannot equal 0 or negative 2. Or it really should be negative 2 and 0. Go from least to greatest. Let me fix that. Oh. Negative 2 or 0. There we go. All right, so let's look at g minus f. Okay, and notice that this is g minus f, not f minus g. So pay attention to the letters here. So g of x is 2 over x plus 2 minus 1 over x. So I need to get my common denominator again. So this is going to give me 2x over x times x plus 2 minus x plus 2 over x times x plus 2. Right? So I know my denominator is x times x plus 2. Now in the numerator, I got to be careful here. This is subtracting this whole fraction. So it is 2x minus x, which is x, and then this is x minus 2 minus 2 here. So is there anything I can? No, I cannot cancel these x's out. No, because there's a subtraction here. X minus 2 doesn't cancel with x plus 2, so that's it. And that is g minus f of x. And my domain is the set of all x's such that x does not equal negative 2 or 0. All right, so now we're going to multiply. G of x is 2 over x plus 2 times f of x, which is 1 over x. So multiplying fractions is super duper easy. I do not need a common denominator. If I got a common denominator, it wouldn't be wrong. I'd just be making things way too hard on myself. I just multiply straight across, and I get 2 over x times x plus 2. I do not even have to distribute, and that is g times f of x. And my domain is still the same. It's a set of all x's such that x cannot equal negative 2 or 0. All right, so then we have the quotient. F of x divided by g of x. So f of x is 1 over x over g of x, which is 2 over x plus 2. So I have a fraction and a fraction, and some of you, I know your anxiety just spiked because, oh my gosh, I have a fraction and a fraction, and I have variables, and it looks ugly, but it is not difficult, so don't freak yourself out for no reason. Your basic rule for dividing fractions is to multiply. When you divide, you multiply by the reciprocal. So this is the same thing as 1 over x times x plus 2 over 2. And then multiplying fractions, super easy. You multiply straight across. So that's going to give me x plus 2 over 2x. Can I reduce anything? No, you cannot. Okay, you cannot cancel the x's out. You cannot cancel the 2's out because you have addition here. So this is f over g of x. Then I have to go and check for my domain. Right? So that means g of x cannot equal 0. I can't just take this. This is not g of x. So g of x cannot equal 0. So that means 2 over x plus 2 cannot equal 0. Right? So like, how would we solve this question? Well, we multiply by the denominator. So if I multiply both sides by x plus 2, I get that 2 cannot equal 0. Is that a true statement? Yeah, it's a totally true statement. 2 cannot equal 0. That is so true. So basically, what it's saying is this function will never equal 0. There's actually an asymptote there, so it can't equal 0, so we're good. I don't add anything else, and my domain remains the same. Set of all x's such that x cannot equal -2 or 0. Right? You try number 5 on your own, or at least some of it, and maybe you have to stop and start, whatever. You can just do it at your own pace, but always try and do some of these without me just telling you everything. Okay, so let's talk about the domains of these first. So again, you can think about them a couple of different ways. I know that I can't take the square root of a negative number. So whatever's under here has to be 0 or greater. Well, what would make this 0? -6 would make this 0. So it can be -6, but it can't be -7, right? So it's -6 or greater. But then also, if you think about it graphically, think about the picture. You know what the parent function looks like, right? So the parent function of a square root looks like this. Well, what does this transformation do? Well, it's inside of here, so that means I translate to the left 6. So I'd be over here at 6, right? And then my function would look like this. So when you think about the domain of this, the domain has to be everything greater than or equal to -6, just like if you thought through it algebraically. So it's the set of all x's such that x has to be greater than or equal to -6. Then here, x minus 2, well, 2 makes it 0, but again, if you think about what's happening, this means I go to the right 2, so it would look like this. So my x values have to be the set of all x's such that x is greater than or equal to a +2. And that's how I come up with those two domains. So then we have to figure out where these domains intersect for our domain over here. So think about that, and we'll get to that as soon as we work a couple of these. So g plus f of x. So g of x is the square root of x plus 6 plus g, I'm sorry, it says g of x plus f of x. See, I didn't read that carefully either. Oh, come on. Okay, so g of x, square root of x minus 2 plus the square root of x plus 6. All right, so what can I do here? Well, nothing, right? That's it, because I can't combine them. I can't, if I was multiplying, that'd be different, but I can't do anything there. So this does equal g plus f of x. There's my answer. That's all I can do. So now, let's think about where these two domains intersect. It's what they have in common. So I have this, the x has to be greater than or equal to 6, and it has to be greater than or equal to 2. So where these two things overlap is right here. And just like if you did a number line, okay, so let's say we had a number line, and we have on here -6 and 2. And I plotted this on my number line. Well, this means greater than or equal to 6 would be right here, and then greater than or equal to 2 would be right here. So where do they intersect? They intersect here. And basically this is the domain for the whole thing. So the domain is the set of all x's such that x is greater than or equal to 2. Then we subtract f minus g. So f of x is the square root of x plus 6 minus the square root of x minus 2. And once again, can't do anything else with that. So that is equal to f minus g of x. And then my domain is the same, the set of all x's such that x is greater than or equal to 2. Now here, I almost wrote this backwards because I wasn't paying attention. And honestly, if I had, it would have meant the same thing, so it would be totally fine. Here, if I write them backwards, that's a problem, so be careful. All right, so then I have g times f of x. So I have the square root of x plus 6 times the square root of x minus 2. So anytime you multiply square roots, you just multiply what's underneath. So this becomes the square root of x plus 6 times x minus 2. And then I need to actually multiply those. So that becomes the square root of, that'll be x squared plus 6x minus 2x. So that'll be plus 4x and then minus 12. Okay? And then I can't take the square root of that. I can't like just take the square root of x or anything, or x squared, and it's not a perfect square trinomial, so this does equal g times f of x, and that's the best I can do. Right? So then my domain is the same as the rest, the set of all x's such that x is greater than or equal to 2. There you go. All right, so f over g of x. This is the square root of x times, I'm sorry, not the square root of x, the square root of x plus 6 over the square root of x minus 2. I have a square root in the denominator. That's a big fat no-no, so I multiply by the square root of x minus 2 over the square root of x minus 2. In the numerator, when I multiply these two together, that's what I just did over here, so I know that the numerator has to be the square root of x squared plus 4x minus 12, and then the denominator is going to be 2. Now, if the square root wasn't there and I could factor the numerator and one of the factors was x minus 2, then I could cancel some stuff out. But I can't, which it would be, because if I factored it, guess what? It would be this. But even if I factored it into this, I wouldn't get to cancel them out because this is under the square root and this isn't. So that's the best I can do there, and that is equal to f over g of x. So now let's talk domain. Remember the denominator, which is g of x, the square root of x minus 2, cannot equal 0. So g of x cannot equal 0. So the square root of x minus 2 cannot equal 0. I square both sides, I get x minus 2 cannot equal 0, so x cannot equal 2. And so I have this. Right now I'm saying that it's the set of all x's such that x is greater than or equal to 2. But now I have to add on to that it can't actually be 2. So the domain is the set of all x's such that x is greater than 2, but not greater than or equal to 2. All right? Okay. So now that's dealing with them with the variables. So we got two things here where we're going to evaluate them. And, sorry. So when I have f plus g of 5, I'm substituting 5 in to each one of these and adding them together. So f of 5 is going to be 4 minus 5 squared plus, substitute 5 in there, 2 times 5 plus 8. Okay, I need y'all to listen very carefully to me. I know that you are very capable of squaring the 5 when you put it in and multiplying the 2 times 5 when you put it in. But one of the most important things you can do when you are working stuff, I don't care how easy it is and how brilliant you are, the first step is zero work. You are substituting it in. You are showing your process. You can't just process it all in your head and have a number there. You have shown nothing. So all I did was literally substitute in. I did not put 25 here and I did not put 10 here. Would I get the same answer in the end if I did? Yes, but remember, the devil is in the details, and we are talking process here. And you are at the stage where process is way more important than the answer. You can do all this in your head and get a number. Great. Guess what? Nobody cares, okay? Because nobody's, that's not what we're testing. We're testing the process. Okay, so even on the super simple stuff, you do that, and you get in the habit of that. So then when it gets more complicated, if you could at the very least substitute it in, even if you have no clue what to do after that, that still shows you understand the process. So it's all about training yourself, okay? So now I can simplify things. Now I get 4 and if you combine steps at this point, doesn't matter. So like I get 4 minus 25, then I know this is 10 plus 8, so I'll put plus 18. That's absolutely fine. I'm not saying you have to show every single painful step, but that first step of substituting, super duper important. Okay, so then my next step, I would probably do 4 minus 25, so that's going to be a negative 21 plus 18. Gives me negative 3, and that equals f plus g of 5. And the other thing that some of you are stubborn and probably leave off a lot of times is I'm not just circling this number. I have to state what my answer really is. Okay? So now I'm substituting in this negative 2. So f, which is 4 minus a negative 2 squared, I'm substituting in, times g, which is 2 times a negative 2 plus 8. I substituted it in, 0 work happened. Okay? So now I'm going to get 4 minus, well, negative 2 squared is a positive 4. So I end up with 4 minus 4. That's 0. And then 0 times anything is 0. So now just saying, oh, guess what? That's 0. Totally fine. F times g of negative 2. There you go. No domains here because you get the actual value. It's not necessary.